we're going to the next CIA TRIAD, which is integrity. And just a recap of what we've covered so far. We'll talk on confidentiality. And we said confidentiality just means that or preventing unauthorized access to sensitive data. And one of the way our organization can achieve or maintain confidentiality is through the process of encryption, where encryption just render that data, make it scramble it, eventually render it useless. Then we also have access control, which just has to do with the privileges or permissions that users are going to have. So a user will be given access to just what they need to perform or carry out their job. And we say access control can be obtained through 3 different steps. The first one being identification, and identification where you just have to put your unique username. And then the second one is authentication. Authentication where you claim your identity by putting in your password. And we said there are other ways of eventually having an advanced authentication algorithm, such as multi-factor authentication, or maybe it can be an iris scan or whatever method that our organization might have. And I also show you all how you can go on Facebook and eventually enable multi-factor authentication. And one of the main benefits of multi-factor authentication is that even if a hacker can get access to your credentials, say your username and your password, but without a second authentication method, then they will still not be able to log into your account. And the last one is the authorization part of it, so that once identity and authorization are good, once your validity has been proven, once your credential has been approved, the next aspect is the authorization part of it, where you are being given access to your company resources, where you're going to get access to different resources, like, the type of information that you're going to see, or it could be your printer, it could be certain files that you have access to. So that's it about confidentiality. The next aspect is integrity, but what relates at integrity is just the assurance to prove that digital information has not been changed, has not been modified, has not been tampered with. And that's why we use the word digital, because integrity now, start thinking of integrity as something over the internet. And as I said earlier in the previous video, once anything has been sent over the internet, you don't have control over that thing. And that's why integrity is really, really, really important. Bear with you, someone might ask me, but we already mentioned of encryption. Since that information is being encrypted, what's the point of integrity? Yes, encryption is just to make sure that if somebody does not have the right key, they cannot access that particular message. But that doesn't mean that hackers does not have like smart way of eventually bypassing some of those encryption algorithms that organizations have put in place. Okay, so and that's why integrity comes in play, because though we have encryption in place, we also want to be able to validate the integrity of that data that we send over the internet. So let's see a method. What are the different methods that one can use to obtain or maintain integrity? The very first one is by the method we know as hashing. Okay, hashing. What really is hashing? So what hashing does is, since this is just like a foundation course, I'm not really going to go in there, but once we start our Security Plus class, then people are really going to understand this concept more better. We're going to go to like the advanced theory part of it. So hashing is just a way of eventually coming up with random characters. Okay, random, very like the length can be of like 32 characters, but a mixture of like uppercase, lowercase, symbols. Okay, you definitely should come with these random characters just to ensure that that particular message is being trustworthy. You can eventually trust the validity of that particular message that has been transmitted over the internet. Let's take a good look at this diagram. So this diagram gives a basic description between encryption and hashing. And if you look at encryption right here, this is what they talk of a plain text. The plain text is a text that the sender, like me today, if I want to send you a message over WhatsApp, or maybe we're communicating on Facebook. So the first message that I'm typing, or I have a file, a Word document that I have typed, no, I have my message there. So that's a plain text because I can read it, right? But in a situation where I want to send, say, that file to you over the internet and have to email it to you, then of course, maybe let's just say I have maybe like we are going with a private key or public key. As I said, we're going to discuss this concept more in depth once we get to our Security Plus class. But with that plain text, the main thing, you cannot transfer in plain text information over the internet, because in a situation where you transfer it and maybe a hacker is trying to get into your network, or a hacker is actively monitoring your network, and maybe a hacker must have installed what they talk of a protocol analyzer that we're going to discuss in depth again, just a way of capturing information sent between two parties. So when that text is being transferred in plain text, if encryption is not there, of course, the hacker will be able to read everything, okay? The hacker will be able to read the plain text, the hacker can modify it, the hacker can eventually make a lot of changes on that particular message. And that's why it is really, really important for companies to adopt this or implement the encryption method to better, protect their data. So once this text is being encrypted, this is what they talk of encrypted text. It can also known as ciphertext, okay? Plain text, cipher text, or encrypted text. Do you see? So when a computer encrypting the number of zeros and ones, that's how computer eventually reads stuff. So just imagine it can be like a whole paragraph and you see these random characters. It really does not make any sense. So that's why I said that it's gonna make it useless. Okay. And of course, you definitely need an encryption key to be able to decrypt. When you decrypt it, you eventually turn it back to a plain text, right? Just as it was in the original form. So you want to read the original content of that text. This is what encryption does. But look at what hashing does. So in a hashing, you have a plain text. And guess what? Though that message has been encrypted, you also have hashing applied there. Okay. So in a hashing algorithm, then you have this plain text. Again, it could be a paragraph that I want to send to you. I want to email it to you. And do you see what we have here? This is, what the hashing algorithm, right? The hash text. So once you have that plain text, once hashing has been passed, then the next one, do you see the end product of this? The end product of the recipient is a plain text. You can read the plain text, but eventually the end product here is still random characters. Okay. It is still random characters. So we're going to explain the next slide, but how are you going to know that this text has not been tampered with? And talking of hashing, the only way you can know that a text has not been tampered with, has not been modified, has not been changed, is by comparing the hash values. Now we have introduced another term. First, we talk of hashing. Now we hash values. Look at this thing here as a hash value. The fact that we have this end product right here, which is a random character, likewise, this is a source. Before you send any information, like a sender, before that sender send out something, guess what? You already hash one hash value. Okay. And by the time the recipient eventually received that particular text, you have a second hash value. And that's why we say we compare hash values. And what hashing does is it eventually have a lot of advantages, right? But the two main advantages is the process of authentication and the process of data integrity. So talking of authentication, first, you want to show that you compare the subject and the object, right? The fact that that object already have a hash value and the corresponding object is also going to check that particular hash value. So by fact that you have that hash value, that's already a way of authenticating that particular file. Okay. So the fact that the hash value, you have it there, that's already a way of authentication. That's why we say that an advantage here is authentication. And then the next one is data integrity. So the data integrity part comes handy where you have to compare those two hash values. So you are comparing those two hash values to make sure that integrity has been maintained, to ensure that that file is trustworthy, to be convinced that no one, of course, hackers have tampered or modified that particular file, of which if a hacker has tampered or modified a particular file, then you cannot trust the integrity of that file. And that's why we talk of the fact that hashing eventually have two main advantages. First one, we talk of authentication, and data integrity. But looking at this patch here, this is what I'm about to explain to you all. If you see on the left, we have the input. This is what you input. This is what you write. This could be your file. Once you put it and it goes through the cryptography hash function, right? Depending on the type of hashing algorithm that your organization use, then you're going to generate, of course, do you see digest? This is like the end product. So you already have this hash value, but guess what? Before the text is being, like before you even have the text, so this is a text, right? Let's say now I want to send the text to a recipient. Guess what? I already have this hash value as a source. I have this hash value. And when that recipient receive it, the recipient should have the same hash value, okay? The recipient should have the same hash value. Do you see it comprises of like uppercase, numbers, and so on. So you should have the same. In a situation where, let's say, a hash value change, say instead of 3 and a recipient got like 2, the integrity of this file cannot be trustworthy. You cannot trust it because it shows that someone has modified it. Okay, but someone might ask, does it mean that you're going to be doing this manually? No, honey, you're not going to be doing this manually, because that's why you have tools that organizations have put in place that eventually checks for this information, right? And some of those tools, by the time they realize that maybe the integrity of a file cannot be, they cannot trust it, of course, it's going to flag it up. It can even block it. It's going to flag it, and then you have the analyst guide that I'm going to go in there to investigate it. Initially, I started my career working as an Oracle DBA, and one of the things that I did was to compare hash values. In as much I didn't quite understood what I was doing, but now it makes sense because I work predominantly with Oracle databases. So especially when I want to go to the Oracle website to download softwares, or like to patch my database, or I want to create a new database, or I want to upgrade that particular database. So I'll go to the vendor site. Of course, my company already will have an account with Oracle. I'll go with my credential. I will download this software. But guess what? Before you even download this software, you already have a hash value attached to it. That's the subject, right? And that's the authentication part of it. So you have this hash value already there. So once I download it, and guess what? Though it's my corporate laptop, but when I am downloading the software, I'm actually downloading it to my client, to my desktop, right? Which is my corporate laptop. But at the end of the day, I have to transfer this file to an operating system. And most of the databases that I work as of that time, I work predominantly with on Linux operating system. So they have a special tool known as WinSCP that you can use to eventually securely transfer a file from your client to the server, to the server where we have our databases. But guess what? Just downloading that file from the Oracle website, I am downloading over internet. Yes, downloading that file over internet and bringing it to my client desktop, it is over internet. Still transporting from my client to the server, it is still over internet. So at the end of the day, when I get to my final destination, when I get to my location where I want to maybe unzip the file, because you download it as a zip file, when I want to unzip that file, the next thing that I'm going to have is a hash value. So I'm going to have a second pair, that's a second hash value. And for me to be able to determine if the integrity of that file has not changed, I'll need to compare the source hash values as well as the recipient hash values. So I need to compare these two hash values. If everything is the same as we have it here, you have, of course, it's going to be unique, not something like what we have here. If it's the same, then I can go ahead and patch I can go ahead and unzip it. I can go ahead and patch that particular database. I can go ahead and create new databases. I can go ahead and maybe upgrade, start doing, play with the commands and start performing my work, right? Or do my job. But in a situation where just a digit or a letter has changed, then of course I cannot trust that particular file. I definitely know that someone have tampered with that file. And that's why you see caching is really important. In as much as organizations have their encryption in place, also hashing is still very, very important to ensure that whatever message that is being sent over the internet we need to make sure that that particular data or the integrity of that data is being maintained. Okay, we can trust it. And in other organizations, they can also hash like password. So once we go to our Security Plus class, then we're really going to discuss in depth. So now this is it for this video. We're going to talk more on the availability part of the CIA TRIAD. I'll see you all in a bit.